what we are going to see today. So I have a camera that is placed here. So this is a B&R OPCA pops up OPCA FX capable device, and this is our controller from TQ Systems. So this is going to send the data here, and it's going to control the IOs here. So I've connected the industrial LEDs to show it in this video. So right now this particular board is already running, but instead of connecting it to one of the ports here, I've connected it to another Linux box here, which runs our test suite, which will show what we are doing here. So let me bring up the test suite, which is part of our ETSN SDK. So you can see this orange line, which is taking the highest priority is the IO, which is the IO data that is being sent from this particular box. So let me keep the screen side by side so that it would be easy for me to explain. So you could see that this particular TQ Systems box is sending the IO signals to using the VLAN ID 3. So it's traffic class 3, and it is able to send with a jitter of plus or minus now for the past 5 minutes, it's plus or minus it's in the range of plus or minus 3 microseconds or 4 microseconds. So I think they went out of sync for some time. I think the synchronization would take more time. So that's why there is some packets that are spread over. But overall, I think the average is the jitter is at the range of plus or minus 4 microseconds. So what do you mean by jitter is, so imagine if the packet has to reach for every 1 millisecond, it either reaches at 1 millisecond plus 4 microseconds or 1 millisecond minus 4 microseconds and nothing beyond it. So this is real time, right? So if your application can live with it, and obviously this would be a very good solution for us. So you can see the other traffic classes are also prevailing, but they are not intruding inside this particular bandwidth that we have allocated. So from the bandwidth 250 to 500 microseconds, we have just allocated it for the real-time data that we are sending, and all the other traffic classes are available in the other windows that we have created. So this we can, let me go back to my presentation. So this we can compare it to the image that we are seeing here. So every traffic class is having equal bandwidth, but here you can see that from 250 microseconds to 500 microseconds, we have just allocated it for our real-time application. So we can be uh, uh, we can rely on this particular network, and the data delivery is guaranteed. Okay, so and also the jitter is plus or minus 4 microseconds, and this would say that OPCA pops up over raw Ethernet is, so now you can see it is getting better because I started it. So it is even plus or minus 2 microseconds. So it's also in the nanosecond. So most of the packets are in nanosecond range and some are spilling out here. So this test suite proves that our OPCA packet is able to be delivered on time. And I have not yet, let me bring the camera image that I'm showing here. So you can see my hand here with my wedding ring, and my wedding ring is here. So I'm not. This is not a recorded one. Okay. So for this purpose, so now what I'm going to do is, so whatever you're seeing left side on the Grafana is running on this particular TQ system from the Up2 Pro board, which is I've logged in using this IP address. So this is part of our ETSN SDK. So now I'm going to remove the cable from here. You can see this. Okay, I don't want to disturb the network. So I just want to remove the cable from here, and you can see that the packets, I've removed the cable. So you can see they will be slowly lost. To see this, let me reduce the time. Uh, because the test suite is not receiving the packet anymore. So it's there for the last 5 minutes. Let me reduce the time slot to 1 minute so that we could see it immediately. So within some time, you can see that this packet is being lost. And I would like to put up the camera stream here, and I'm going to connect it uh, to this particular slot. You can see slowly, I'm not yet connected. I just want to make sure that you are able to understand that I've removed it from the TQ systems. And then since there are no packets received, I think within few seconds, we will lose all of them. It's just 1 minute, last 1 minute. So we are able to do it. So quickly to recap, what we have done so far is we have seen that uh, we are able to understand that OPCA variables can be accessed by client-server communication and also pops up over raw Ethernet, pops up over UDP, pops up over MQTT for various purposes, like according to our QoS needs of the network. And we also saw an experiment that we are able to prove that, okay, now it's gone. So all the packets have gone because it's only last 1 minute. And now I'm going to connect this particular uh, Ethernet cable that comes from here. So you can see this white flat cable. The same white flat cable from the TQ systems is going to be connected peer-to-peer to this particular B&R bus coupler, which runs OPCA FX, and I'm going to connect it here. So this particular LED that is blinking is the time synchronization. So it has settled down, and then it shows that it is in time sync. And then these are the LEDs here, and you can see that the LEDs are blinking in a ratio that so it is just a counter application that we have done, just a LED blinking application that we have done. And I have a GUI that is in front of me, but due to some technical difficulties, I could not share the screen here, but I'm going to increase the speed. Now you can see the LEDs are blinking in a faster rate, and I will make it more fast, much faster. Yeah, you can see literally it's so fast now, and I'm going to bring it back. So this is the overall application to show that we are able to send a packet for every 1 ms, and we are toggling these LEDs. And this particular board is running OPCA FX ETSN SDK, and this is from B&R Bernecker and Rainer. It's an Austrian-based company who have the support for OPCA FX for this particular IO module. And we are also having a Qt GUI that controls the speed of the LED. So right now, since I've completed this demo, I'm going to take a risk of moving this camera and quickly show the Qt GUI here. So this is the Qt GUI that I spoke about. So when I'm going to increase the speed, let me increase the speed of the LEDs. So you can see that the LEDs has increased the speed, and now I'm going to reduce the speed. And then, okay, I did not make a click. Okay, so now you can see that the speed has decreased. And now I will go further, and then you can see that the LEDs have slowed down. And also, we can quickly see the Wireshark trace if possible. I will need to open a terminal. Yeah. Okay, and I need to, so just give me a moment. Yeah, my friend is going to help me here. Can you type the password? Yeah, you can say hi to Surya. Yeah, okay. So it runs on ENP. So this particular TQ systems board has 4 ports, and I'm going to, so you can see that these are the PubSub packets, and I'm going to stop it. And you can see this is uh, the data that we are sending, and this particular one that you're able to see here is the each LED. So every time, okay, let me go down. You can see that that particular one is okay. It has other packets as well, so I just need to filter them out. Let me filter it. Okay, and this will be clear for you guys now. So okay, I just filtered out the wrong packet, but this does not this particular PC does not have a filter for us, but at least you can see this VLAN ID that we are sending. So the critical application is sent at priority code point 3 and VLAN ID 2, and we are sending the data pops up data packed as a UDP packet here. So this is what is happening right now. Yeah, so with this, I am completing my uh, webinar today.